In this video, we're going to take a look at an example that is the relationship, or at least part of the relationship, between physics and calculus. And so our problem here is, suppose the height of an object dropped from a building is given by an equation here. S of t is 200 minus 16t squared, and that is in feet. How long will it take the object to hit the ground? Right? So we want to know, on this first question, when will its position, that's S, when will the position be 0? So 200 minus 16 t squared, when is that going to be equal to 0? And we can go through and solve this. You could use your quadratic formula. Because this only has a t squared term and no t term, you could add 16t squared to both sides and then divide by 16 and take the square root. At any rate, when you do this, you will find that our value for t is approximately 3.5355 seconds. So there, that part of the question is just algebra. We're solving this. Next, we want to find the velocity of the object after 2 seconds. So we have the position function. How do we find a velocity function? Well, our velocity function is the derivative of the position. And so if we take the derivative of that, we get negative 32t, so derivative of 200, that's the derivative of a constant, is 0, minus the derivative of 16t squared. We brought the power down, subtract 1 from the power. Now we want to know specifically what is the velocity after 2 seconds. So after 2 seconds, the velocity is negative 32 times 2, negative 64. The units on this, those were in feet per the unit of time, second. So feet per second. The velocity is negative 64 feet per second. And if we wanted to know what is the acceleration of our function, the acceleration of our function, of our object, is the derivative of our velocity, the second derivative of position. If we were to take the derivative of negative 32t, that derivative is negative 32. It's feet per second, or feet per second squared. So the rate of change. And that's a constant acceleration. It's acceleration due to gravity in a vacuum. All right, that is all that we have for this section. We will talk to you again later.